Maximizing our grade with maximums, minimums, points of inflection, and concavity. Our end of the year project by
Ansley Smith,
Hunter Bullock,
and Myles Williams.
Let's start with the maximums and minimums. A few points to remember are: find the derivative of f of x. You want to find your critical points where the derivative of f of x equals 0 or is undefined. And lastly, use the line test to find the maximums and the minimums.
For points of inflection and concavity, remember that a point of inflection is always a coordinate in the form of a, f of a. You want to find the second derivative for f of x, and again, where this equals 0 or is undefined. Finally, use the line test to find concavity and intervals.
But how does the line test work? Plug in values around the critical points that you found. When the second derivative changes from a positive to a negative value, this indicates downward concavity. When the value changes from a negative to positive, this is upward concavity.
So let's practice with an example. Say we're given the function f of x equals 3x to the fourth minus 4x to the third. Our first step is to find the derivative using the power rule. This gives us 12x to the third minus 12x squared.
Next, we find all of the possible critical points.
Wait, what are critical points exactly?
Critical points, also known as extrema, maximums, or minimums, where the derivative of f of x equals 0 or is undefined. We can find these points by setting our first derivative equal to 0. Doing so, this results in x equals 0 or x equals 1.
In order to find our points of inflection, next we draw a number line and plug in x values around our critical points into the first derivative. Let's try -1, 1/2, and 3/2. This is our first derivative's line test.
Plugging in these values gives us negative, negative, positive. Since the value changes from negative to positive, we can state that x equals 1 is the point of inflection.
When finding concavity, we want to repeat the same steps, but instead of using the first derivative, we will use the second. After finding the second derivative, 36x squared minus 24, we set the value equal to 0, resulting in x equals 0, or plus or minus root 3/2.
After plugging in our points around our extrema, our result is positive, negative, negative, positive.
Our resulting answer is that we have one point of inflection at x equals 1 and both upward and downward concavity.
Created using Powtoon.